The goal of an in vitro fertilization cycle today is to provide one cycle of IVF whereby one embryo is transferred, producing one healthy child. How can the IVF laboratory maximize the development of blastocyst embryos? The design of the IVF laboratory should reflect a controlled environment imitating in vivo conditions. The setup of the IVF laboratory should pay great attention to maintaining sterility, temperature, humidity, and appropriate lighting. The laboratory should have a heating, air conditioning, ventilation system compatible with the dimensions of the space and the amount of equipment and personnel. The system should operate under positive pressure ventilation with high efficiency particulate air and charcoal filtration. The embryology laboratory design should allow close proximity to the procedure room used for egg retrieval and embryo transfer. The laboratory should be situated where its environment can be controlled and where exposure to traffic, vibration, and atmospheric agents are minimal. The laboratory should have equipment appropriate for the culture of embryos. The laboratory should have appropriate laminar flow hoods to work sterilely, isolates to maintain temperature and pH, incubators both for setup and culture, microscopes with appropriate heated stage. The laboratory should also have auxiliary equipment to measure conditions in the laboratory, such as CO2 meters to measure CO2 levels in the incubators, pH meters to measure the pH in the culture media, and hygrometers to measure the humidity within the laboratory and inside the incubators. How can the IVF laboratory maximize the development of blastocyst embryos? The design of the IVF laboratory should reflect a controlled environment imitating in vivo conditions. The culture system should meet the needs of a cleavage embryo to develop into a blastocyst. The culture system should be evaluated routinely to assess its ability to create viable blastocyst embryos capable of producing live births in both fresh and subsequent frozen cycles. Avoid the impulse to introduce new items into your culture system and focus on reducing stressors that may affect the ability to produce the most competent, viable blastocyst embryos. The laboratory should use an intact culture media system designed for blastocyst culture. You should select and validate a culture media system that produces highly competent and implantable blastocyst embryos. The laboratory should utilize all the media and reagents consistent with one vendor, thereby reducing shock to the embryo induced by the introduction of different base components, buffering systems, or pH culture requirements. Care should be taken when storing and handling all media solutions used for culturing embryos in the IVF laboratory. Culture media is not inert and reacts rapidly to the climate and atmosphere of its surroundings. Media should be utilized within the manufacturer's reported expiration date and stored refrigerated until usage. Culture media should be opened using aseptic technique in a laminar flow hood and used within 5 days of its first opening. Do not use any media solutions if the packaging appears damaged, the seal is broken, any of the solutions appeared turbid, or the expiration date has been exceeded. Culture oil should be washed with culture media and pre-equilibrated before usage. A culture strategy should be chosen that provides and maintains the stable environment of temperature, humidity, and pH, is simplistic in function, and develops and supports the most competent embryos. Prior to placing any oocytes or embryos into culture, culture dishes containing any type of media should be pre-equilibrated for temperature, and if bicarbonate buffered media are utilized, for pH. Equilibration time should be at least 4 hours, although recent studies demonstrated that an 8 to 10 hour equilibration window was needed to stabilize target pH in culture dishes. Equilibration time should not exceed 18 hours, as the degradation of amino acids, protein sources, vitamins, and the antibiotics will begin. Limit embryo observations as a way to decrease incubator door openings and decrease embryo exposure to unnecessary changes in temperature or pH. Thermal control is one of the most important culture system variables in the IVF laboratory and requires close attention and management. Oocytes and embryos are particularly sensitive to alterations in temperature. Since incubators and warming surfaces and devices are prone to drift in and out of calibration during normal operation, the IVF laboratory should use equipment with a steady temperature profile. The laboratory needs an adequate number of incubators to alleviate excessive door openings and fluctuations in the thermal and gaseous phases of the incubators. Separate incubators for media equilibration and embryo culture should be used in the laboratory to minimize the embryo's exposure to unnecessary temperature and pH shifts. Understand the operation of your laboratory's incubators to have the most efficient recovery of temperature, humidity, and gaseous state. Oocytes, cleavage stage embryos, and blastocyst embryos require different pH environments during culture. pH should only be adjusted by titrating CO2 levels in your incubator. Directed daily management of pH values is essential since every laboratory's environment is different due to many parameters, for example, equipment, culture media, plasticware, temperature, humidity, and/or altitude. Rapid deequilibration of both temperature and pH occurs after the removal of culture dishes from the incubator, usually in less than 10 minutes. Culture dishes re-equilibrate slowly due to the relative magnitudes of the differential CO2 contents between the equilibrated medium, the air, and between the incubator's atmosphere and the partially outgassed medium. Oocytes and embryos are extremely sensitive. Rough handling of oocytes and embryos during their processing can cause irreparable damage. Using a pipette that is too narrow or with a jagged edge can also cause damage to the oocyte or embryo. Diameter of the pipette should be slightly larger than that of a cleavage stage embryo or the blastocyst embryo. Embryos should be washed gently multiple times through multiple drops of media when moving embryos into new dishes, especially when they contain a different media type. How can the IVF laboratory avoid no or poor quality blastocysts for transfer? The laboratory should have in place functional quality assurance and improvement programs that enable the monitoring of key laboratory performance indicators. The laboratory must be able to detect laboratory variations beyond usual and accepted before the results manifest into a less than desirable clinical outcome. The laboratory should be proactive instead of reactive. Attention to fine detail and monitoring relevant laboratory indicators will assist the laboratory in maintaining high blastocyst production rates. Each patient should have their dishes prepared individually. No more than 2 culture dishes should be prepared at one time as to avoid evaporation of the media. All culture dishes should be labeled with the patient's name, unique identifier, and dish type. When making drops of medium, use a single wrapped pipette tip, rinsing the tip twice with culture medium before making the droplets. The day before oocyte retrieval, commonly referred to as day -1, dishes should be prepared late in the day and allowed to equilibrate for at least 8 hours prior to usage on day 0, in an incubator set to attain manufacturer's specified pH. You will need to prepare 2 organ well culture dishes with 1 ml of Quinn's Advantage Fertilization Plus media in the center well, overlaid with 1 ml of culture oil, and 3 ml of Quinn's Advantage Fertilization Plus media in the outer well. This dish will be used to retrieve oocytes and wash them before they're placed in their maturation dish. You will also need to prepare a 60 millimeter culture dish with 6 200 microliter droplets of Quinn's Advantage Fertilization Plus media along the outside periphery and 1 200 microliter droplet of Quinn's Advantage Fertilization Plus media in the center, overlaid with 11 mL of culture oil. For post-ICSI dishes, 2 35 millimeter culture dishes with 5 30 microliter droplets of Quinn's Advantage Cleavage Plus media should be made. This dish is then overlaid with 3.5 milliliters of culture oil. To prepare sperm for insemination, 8 mL of Quinn's Advantage Fertilization Plus media will need to be equilibrated overnight in the incubator. On the day of oocyte retrieval, commonly referred to as day 0, dishes should again be prepared late in the afternoon and allowed to equilibrate for at least 8 hours prior to usage on day 1 in an incubator set to attain manufacturer's specified pH. You will need to prepare 2 35 millimeter culture dishes with 5 30 microliter droplets of Quinn's Advantage Cleavage Plus medium overlaid with 3.5 milliliters of culture oil. On the afternoon of day 2, dishes need to be prepared for extended culture. These dishes will need to equilibrate for at least 8 hours prior to usage on day 3 in an incubator set to attain manufacturer's specified pH. The laboratory will need to prepare 2 35 millimeter culture dishes with 5 30 microliter droplets of Quinn's Advantage Blastocyst Plus media overlaid with 3.5 milliliters of culture oil. 4 milliliters of 75% SPS plus 25% Quinn's Advantage Blastocyst medium will need to be prepared for washing catheters and the transfer of embryos. In addition, the laboratory will need to prepare 10 mL of Quinn's Advantage Herpes media for vaginal lavage wash. In summary, the results are in the details. The laboratory should pay close attention to the usage of an intact culture media system designed for blastocyst culture, maintaining thermal and pH stability, the appropriate application and equilibration of culture media, appropriate manipulation of zygotes and gametes, and minimizing embryo observations. Frequently, what is considered some of the most insignificant, minute details of culturing embryos can collectively contribute to the success of developing viable blastocyst embryos and performing elective single embryo transfer routinely.